Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC B1176, pertains to a fault in the fuel level sensor, also known as the fuel gauge sending unit, within Honda Civic models from 2011 to 2015. This code is triggered when there is a short circuit in the sensor circuit, impacting the functionality of the fuel gauge. The fuel level sensor is crucial as it provides the vehicle's fuel gauge with accurate readings of the fuel level in the tank, allowing the driver to gauge how much fuel is available. When this circuit short occurs, it may cause steady incorrect readings, erratic gauge behavior, or a blinking low fuel indicator. Understanding the implications of this error is vital for efficient diagnosis and repair, ensuring correct fuel level indication to prevent running out of fuel unexpectedly. The fuel level sensor, commonly known as the fuel gauge sending unit, is a critical component located within the fuel tank of the Honda Civic. Its primary role is to accurately measure the level of fuel in the tank and send this information to the gauge on the dashboard, providing the driver with a clear understanding of the remaining fuel. Positioned within the tank, the sensor can directly respond to changes in fuel level, ensuring updates on the gauge reflect the current state of your fuel. If this unit fails or experiences a short in its circuit, the fuel gauge may display incorrect information, potentially leading to alarming situations for the driver. Therefore, any issues with this component need immediate attention to maintain reliable vehicle operation. Several possible causes can lead to the trigger of DTC B1176. Firstly, a failure within the fuel gauge sending unit itself can disrupt the entire circuit and cause erroneous readings. This could stem from wear and tear, mechanical damage, or electrical issues within the unit. Secondly, if the wiring harness experiences a short, particularly in the fuel gauge plus line, it can result in the fuel gauge displaying erroneous readings. Additionally, loose or poor connections in the electrical system can lead to intermittent failures, where the gauge behaves erratically or fails to convey fuel levels accurately. Identifying the root cause through structured troubleshooting steps is paramount to effectively addressing this issue. When experiencing DTC B1176, several symptoms may present themselves, indicating a problem with the fuel gauge. The most evident symptom is that the fuel gauge may not respond at all, remaining stuck or not moving as fuel is consumed. Furthermore, the low fuel indicator could blink, which is an alert that the system is detecting an irregularity. Drivers may also notice erratic readings, where the gauge fluctuates unpredictably or shows levels that do not align with the actual fuel present in the tank. These symptoms not only confirm that there is an issue, but also pose a risk of running out of fuel due to inaccurate readings. The first troubleshooting step involves verifying the functionality of the fuel gauge. Start by checking if the fuel gauge moves to the full position, accompanied by observing if the low fuel indicator is blinking. If the gauge responds correctly, this implies that the system may be functioning adequately and indicates that the issue could be intermittent, meaning you should further inspect for any loose or poor connections in the system. If the gauge does not move or behave normally, this will lead you to step 2, where a more in-depth examination of the fuel gauge operation will take place. Being thorough in this first step is critical for isolating the potential faults before proceeding further in the diagnostic process. The second troubleshooting step focuses on checking the operation of the fuel gauge. To start, ensure that the ignition switch is turned to the lock position. Following this, disconnect the fuel gauge sending unit's 4P connector, essentially isolating the unit from the electrical circuit. Next, turn the ignition switch to the on position. At this point, Verify if the fuel gauge moves to the empty position. If it does, this indicates that the fuel gauge sending unit is faulty and replacement is necessary. If the gauge does not move, it implies that further checks are warranted, and you will proceed to the next step to examine the wiring connections and module functions. The third troubleshooting step is pivotal in diagnosing potential wiring issues within the circuit. Begin by turning the ignition switch to the lock position once again. Next, you will need to disconnect the gauge control module's 32P connector, which isolates the module from the circuit for testing. Ensure that the fuel gauge sending unit's 4P connector remains disconnected, as this test aims to identify any continuity issues in the fuel gauge plus line. Check for continuity between two test points. Test point 1 being the gauge control module's pin number 22, and test point 2 being the body ground. If continuity exists, this indicates a short to ground within the wire, necessitating repairs to rectify the issue. If there is no continuity, it suggests that the gauge control module itself may be faulty and require replacement. After performing the required repairs based on the findings from the previous troubleshooting steps, it is critical to verify that the repair was effective. Start by checking the operation of the fuel gauge once more to ensure it responds accurately to different fuel levels. Furthermore, examine all electrical connections made during the repair to confirm they are tight and secure, preventing future issues. If the gauge reacts correctly and all connections are in place, this indicates the repair was successful. If any problems persist, it may be beneficial to revisit the troubleshooting steps for further investigation or consult a professional for an independent assessment. Preventive maintenance is essential for avoiding future occurrences of DTC B1176. To maintain the integrity of the fuel gauge system, regularly inspect all connections associated with the fuel level sensor and gauge control module for any signs of wear, corrosion, or looseness. Ensuring that the connectors are secure and free from dirt or moisture can significantly reduce the chances of intermittent failures. Additionally, keeping an eye on the wiring integrity throughout the vehicle is paramount. Look for frayed wires or signs of damage that could lead to shorts. Establishing a routine for these checks aids in prolonging the lifespan of the fuel gauge system and ensuring accurate fuel level readings. In conclusion, DTC B1176 points to a critical issue with the fuel level sensor circuit in Honda Civics from 2011 to 2015. The diagnostic steps outlined provide a structured approach to identifying and resolving the root causes of the problem, whether that be a faulty sending unit, a shorted wire, or loose connections. Understanding each component's role in the fuel gauge system is essential for effective troubleshooting and repair. Furthermore, performing regular preventive maintenance assures that the fuel gauge operates reliably over the life of the vehicle. By following these guidelines, you can ensure that you manage the fuel levels accurately and avoid potential issues in the future. Please like and subscribe to the channel. See you next time.